So also another reminder is that the midterm exam got posted yesterday morning. So I know a couple of you guys have already been looking at it, which is great. If you got to the end and you got a little bit confused, that's because the last couple questions on the exam have to do with the stuff that we're going over today. So if you already went through the exam once and turned it in, but we go over some stuff today and you realize you may have made some mistakes, you're more than welcome to go back and redo your exam. Again, it's not due until Friday evening. So you can take it as many times as you want between now and Friday. I'm just going to look and grade whichever your most recent submission is by the end of the day on Friday. So that's up again. You still have another day and a half to work on it. So take your time, go through it slowly, make sure you understand the questions. And as always, you can go back to your notes and the videos that I've posted for you guys to try and help you out. Obviously, since it's an exam, I can't directly help you with the questions. Like if you ask me like, hey, how do you figure out the answer to this one? That I cannot tell you. But if you have a question like, hey, I'm not sure how I'm supposed to answer this, or Mr. Stanley, I'm not really sure what this question is asking, that I can help you out with. If you reach out to me with a question like that, I'll do my best to try to explain it and maybe make the question a little bit more clear. All right, so I think that is pretty much the main announcements that I wanted to hit you guys with today. So up next, we'll move on into our notes for today, which is going to be all about things called mixtures and compounds. So we've been talking about the last day on Tuesday. We went over those covalent bonds and those ionic bonds and how atoms stick together. And so today we're going to talk about what do we call it when we have different groups of atoms sticking with each other. So the notes are the September 24th Thursday notes on mixtures and compounds. And as always, I'm recording me going through the notes right now. So if you go back to the top of our Google Classroom under the Zoom class video section, I'll have a new tab for elements and mixtures notes, or mixtures and compounds notes, where I'll post the video of the recording of me going through the notes with you guys today. All right, scrolling down. September 24th, Thursday notes. Let's get it. All right, make sure you guys are still, yep, looks like it. Sometimes I like to stop and double check and make sure that you guys are seeing what I'm seeing, because Zoom likes to be a little bit tricky sometimes and not tell me when you guys are looking at something different than what I'm seeing. But with that being said, we'll get into the notes for today, all about the classification of matter. So if you remember, matter is just our fancy science word for stuff. Everything in the universe is matter. And so today we're going to talk about how can we group these different collections of substances and particles into kind of different categories, into different groups. So I'm going to give you sort of a broad overview of everything in this one big flow chart. And then we'll go through what are pure substances. We'll talk about what are mixtures. And then at the very end, we'll circle back to this flow chart where hopefully things make a little more sense than they did the first time that we went through. So if we start off with the matter, so matter is everything made out of atoms in our universe, which is so far everything that humans have discovered. And our matter can be split into either a type of mixture or a type of pure substance. If it's a mixture, that means it has different kind of pieces and substances or particles all mixed around together in it. But if we wanted to, we could go in and physically separate out those particles. So we could put it through a filter paper of some kind, like a coffee filter, if we wanted to filter out the big particles from the small particles. We could apply some sort of like magnetic or electric field and separate them out based on what's a magnet and what isn't. We could look at the color of our mixtures and separate it out based on these ones are one color, these ones are one other type of color. So that's what we mean by physical means. If we wanted to, we could go into our mixtures and physically separate the pieces into different substances. If there's only one type of substance present, it's not a big mixture, there's only the one single type, that's when we have a pure substance. So like completely pure water that's been super heavily filtered so that only H2O molecules are present, that would be a pure substance. Or like the oxygen tanks that sometimes elderly people and people with breathing issues have to wear in order to make sure that they're getting enough oxygen into their system. The oxygen in those tanks is pure oxygen. There's no other type of particle or substance mixed in there. So that's what makes that also a pure substance. And like I said, in a little bit, we'll go down and break apart these pure substances and these mixtures and kind of talk about what exactly we mean by each one. So our mixtures, we can kind of separate into two different categories based on if it has uniform composition, which is essentially just a fancy science way of saying everything is totally equal and the same. If it is, then it's what's called a homogeneous mixture. Everything is all even and the same. If it's not all equal, if there's clumps of matter in this section, but this area is really empty, then it's called a heterogeneous mixture. On the other side, if we have a pure substance already, then we can think about it in two ways. If it's made up of some different atoms that have bonded together, right? So they have either an ionic bond or a covalent bond that's kind of sticking them together, like we were talking about on Tuesday. Then we have what's called a compound. So the decomposed by chemical means essentially just means, does it have different atoms in it that we could do some sort of reaction to separate those different atoms? If it does, it's called a compound. If it doesn't, if there's only one single type of atom present and that's it, then it is an element. So I'll talk about some more examples of these guys in a second, but if we think about what I was just talking about earlier, our pure water, so 100% water, that would be a compound because water, H2O, 2 hydrogen and 1 oxygen atom all bonded together. So because we have different atoms in there, it is a compound. On the flip side, the oxygen and the oxygen tank that people use to help them breathe, that is purely an element. So only oxygen, the atom oxygen, is in that tank. It's all oxygen inside of there. Nothing else is combined or mixed with it. So this is kind of the very broad outline of what we're going to be talking about today. And so up next, we're going to go into some more detail on these compounds, elements, and the different types of our mixtures. So first up, we'll start with the right-hand side of that big flow chart we just went through, which are the pure substances. So a pure substance is when only one single type of particle is present in a substance. So in both of these pictures, we have a pure substance because each one only has one type of particle. In our first picture, we only have the single black dot particles that are all on their own. In this other picture, we have a combination of 1 black dot and 2 white dot particles. But this is the only type of particle in here. So every single, if we were to expand this picture out, if we had a pure substance, every single particle would look like the identical twin of these guys. So that's what we say when we mean one type of particle. We don't mean only one type of atom, right? Because this pure substance has white and black atoms, but they're bonded together in these particles. So if this type of particle is the only one that's in our substance, it is a pure substance. So I mentioned that we can divide our pure substances into two different groups. We have our elements, so those single atoms just of themselves, or our compounds, where we have two or more different atoms, but they're bonded to each other. So they're physically connected to each other. Any questions so far on what a pure substance is? All right, awesome. So up next, we're going to talk about each of these guys in a little bit more detail. So we'll start off with our elements. Remember, this is when we have matter that's composed of completely identical atoms. So every single atom in a pure substance that's only one element is the exact same. So like this pot over here is like an ancient Greek pot or something made out of copper. So every single atom in this pot right here is a copper atom. There's no other like oxygen or tin or iron or anything mixed in there. It is 100% pure copper. Same thing with this gold bar over here. So gold is one of those weird atoms where it has kind of a funny chemical symbol for its name. So the symbol for gold is AU. And in this pure substance of gold, all these bars are made out of 100% pure solid gold. And so there's no other atoms that are mixed in with the gold in here. There's no silver, there's no oxygen or iron or anything like that. They are totally and 100% only gold atoms that are in there. So because each one of these things is made up of one single type of atom, it is a pure substance that is made of one element. So what happens if we don't only have that one element in there? What if there's a couple different ones that are all bonded together? That's where we end up with our compounds. So compounds are when we get two or more different elements bonded together, right? Stuck together either through an ionic bond or a covalent bond, like we were talking about on Tuesday. So if this compound, whatever it is, if we have these different elements bonded together, if every single particle, every single molecule in our substance is made up of the exact same compound, then it can still be considered a pure substance. There might be different atoms, right? There might be different elements that are in there, but they're bonded to each other, and every single molecule is an exact same copy of that compound, which keeps it being a pure substance. So when these atoms bond together, they end up having properties that are different from the individual atoms when they're separated. So our famous example that we talked about a whole lot on Tuesday is sodium chloride, also known as table salt. So sodium chloride is that ionic bond, right? Sodium had that one little atom, or that one little element that was floating on his outer shell. Chlorine had 7 electrons on its outer shell and wanted that one from sodium. So sodium transferred his electron over and then became a little bit positive. Chlorine took that electron, became a little bit negative, and the positives and negatives attracted each other and held those guys together. So obviously everybody knows what salt is. You put it on your food to make it taste better. But when they're on their own, sodium and chlorine are actually very, very dangerous elements. So pure sodium is a metal that is incredibly reactive with air and water. It will literally start sparking and giving off smoke and lighting on fire if it comes into contact with any amount of air or water. Chlorine, on the other hand, is a nonmetal, so it's normally a gas that can be extremely toxic to people in relatively moderate amounts. So we have this potentially explosive metal, we have this toxic gas that's nonmetal, but when they come into contact with each other, they make those ionic bonds, form this big crystal structure, and end up being what we call table salt. So if inside this vial of salt shaker was only sodium chloride compounds, there's just billions and billions of them in there to give us this amount of salt, then we could say that this salt is a pure substance. There's no other compounds in there that are messing with the salt. It's a 100% pure sodium chloride. So some other compounds that are pretty common in everyday life and that you may have heard of before include things like water, right? So water is 1 oxygen and 2 hydrogen atoms that have bonded together. So different atoms bonded together gives us our compound. And then if this water right here was 100% only H2O, there's no added minerals or anything from the water source, it's been super duper filtered and purified, then that's what would give us our pure substance of water, because there's only H2O molecules that are floating around in here, no other types of compounds or elements. Carbon dioxide, another compound that you may be familiar with. We breathe it out of our bodies every time you exhale. It comes out of the exhaust pipe of our cars, and it tends to be given off in large amounts by coal burning power plants when they're creating electricity. Again, 2 different atoms, 1 carbon and 2 oxygen atoms bonding together to give us 1 carbon dioxide compound. And then finally, a compound that I'm sure a lot of you are familiar with and big fans of, ethanol, which is the alcohol that goes into the drinks that we drink. So scientifically speaking, there are a whole bunch of different types of alcohol out there, but ethanol is the one that's in our alcoholic beverages. So beer, wine, gin, vodka, the thing that gets you drunk in there is the ethanol. So ethanol is 2 carbons, 5 hydrogens, and a oxide group, which is an oxygen and hydrogen together, all bonded together into 1 small little chain. So again, ethanol is a compound because it's multiple different elements that are all chemically bonded together. They're all stuck together. All right. Any questions so far on pure substances, elements, or compounds? Everybody feel pretty okay with this stuff so far?
Yes.
Yeah.
All right, sweet. All right, so if those are our pure substances, right? If we only have one single type of atom, or we only have one single group of atoms, one single type of compound in there, it is our pure substance, right? Only one atoms that make up our elements, or only one type of compound. If that is not the case, if we have lots of different elements and compounds all combined together, that is what gives us our mixtures. So our mixtures are when we end up with two or more different pure substances, right? So in this mixture down here, we have multiple different types of particles all mixed together. So we have this little black dot element right here. We have this little double white dot element. So this guy is still an element because even though there are two atoms, they are the same atom. So this would be like if we had two hydrogen atoms or two oxygen atoms stuck together. Since they're both the same, they're still an element. This is not a compound. Instead, our compounds are something like these guys down here. All right, so two or more different atoms together is a compound. And then when we get different elements and compounds all combined together, it's no longer a pure substance, it is now a mixture. All right, so like we were talking about earlier, ethanol is a compound. So if you had something that is used for like sterilizing stuff, it might be 100% ethanol. So that'd be the only thing that's would be in that. But usually the drinks that we drink with ethanol in them are only what, between 5, 12, 20, 40% ethanol. The rest is water and different flavor combinations. So like beer is a little bit of ethanol with a lot of water and wheat grains mixed in and filtered out. So we have all sorts of different combinations of these particles that come together to make that drink. So when we get those different particles, those different substances, we have a mixture on our hands. It is no longer a pure substance. So we can kind of break down our mixtures into two different categories. Our first one is called a homogeneous mixture, also known sometimes as a solution. And homogeneous mixtures, as you might be able to tell from the name, are when all of the different particles in this mixture are totally equally and evenly distributed throughout the mixture. So the reason that I mentioned that you might be able to tell from the name is homo is a Latin prefix that means the same or equal. So homogeneous mixture is equal and even distribution of all of our different particles. Homozygous gene, so the genes in your DNA can be homozygous or heterozygous. Homozygous is when they have the same copies of the gene on each set of DNA that you have. And then homosexual relationships are the scientific term for gay people, meaning that they're interested in the same sex, right? The same gender as them. And so homo means the same. So homogeneous mixtures are where everything is the same. Everything is equal and even. Normally this happens when you have very small particles in your mixture, because then that's how they're most able to equally kind of disperse themselves in the solution. And the particles are never gonna like settle on the bottom. So you know how sometimes if you leave like some types of salad dressing in the fridge for a while, and then you take them out and you have to mix them up really good because there's like a little bit different oil layer and water layer. That doesn't happen in homogeneous mixtures. They'll never separate, they'll never come out of the solution. They'll always be completely equally distributed. So one area where we see homogeneous mixtures a lot is in things like medicine. So these eye drops right here they're not a pure substance because they're a mixture of water and saline, which is like a salt solution, and some medicine for your eyes. Maybe it'll help make them like be a little less red or something if they're really irritated. So it's not a pure substance. It's got these different compounds in there, but each drop that comes out of the little dropper bottle of saline in here should be the exact same as the previous drop, right? If you're putting these in your eyes at different times of the day, you don't want there to be sometimes a lot of medicine in your drop and sometimes almost no medicine in your drop, and it just feels like you put water in your eye. So you always get the same combination of particles in every drop because they're completely equal from top to bottom of the little jar that's in here, of this little dropper bottle, right? They're not clumped up. There's no areas where the medicine is way more clumped up and areas where it's way more spread out. It's all totally equal and even. So some other examples of kind of more everyday things that are homogeneous. Things like mouthwash. So every time that you swirl that mouthwash around in your mouth, you should be getting the same mixture of water and alcohol and antiseptic and flavoring from the mouthwash. And again, you can see it's totally clear. If you took the little label off the bottle, all of the areas of the mouthwash bottle should look the exact same because all of the different compounds that are mixed in there are totally evenly spread throughout. Same thing with white vinegar. So vinegar is a mixture of a compound called acetic acid and water. And again, you can see the bottle totally clear. All of the acid molecules and water molecules are totally evenly spread out. So every capful of vinegar that you pour out, whether you're gonna season some food or clean some stuff with it, should be the exact same, right? The vinegar shouldn't be getting any stronger or any weaker as you get more towards the bottom of the bottle. Same thing with coffee, specifically from like a drip, like a normal drip coffee maker, because all of the coffee bean particles have been held up by that filter paper, at least they should be if it's doing its job. So the only things that should be dripping down into your coffee pot should be the hot water and all of the coffee flavors and caffeine that it took out from the coffee beans. And so every sip from this coffee pot should taste the same as the last one, right? You shouldn't be getting any weaker coffee as you get more towards the bottom of the pot. It should all be the same because all of those little flavor and water particles are all evenly mixed together. Then one of my personal favorite examples is like smooth peanut butter. So peanut butter is a combination of ground peanuts and oil and a little bit of sugar. And so each scoop that you get out of your jar of peanut butter should taste the same and look the same as the last scoop, right? As long as they mixed everything together really well, it should all be completely homogenized. It should all be totally the same. So what happens when we don't have everything all nice and the same? What if we get big clumps of particles in one area and then a lack of particles in another area? When that happens, it's no longer a homogeneous mixture. It is now a heterogeneous mixture. So if homo means the same, then hetero means different, right? If you are in a heterosexual relationship, that means that the two people in the relationship are different sexes, different genders. In a heterogeneous mixture, the different areas of the mixture will be different. They're not all going to be the exact same. Things are uneven. So maybe there's more water in one area, but more grounds in another area, but more acid over here. It's not completely evenly mixed together. You get clumps and bare patches of our different types of compounds and elements. So like granite right here is a good example of this. So you can see if you look at this picture, there's all these little white and gray and black kind of specks all distributed throughout the granite. So if granite were totally homogeneous, if everything was equal, it would look just like one clean, even gray kind of smear or wall. Instead, all of the different minerals that make up granite, so rocks are just a combination of minerals, and granite is a type of rock. All of the minerals that make up granite are not evenly distributed. They are unevenly mixed together. So that's why you see all these little patches of these black minerals, and then all these little spaces with the white minerals and the gray minerals. They're all unevenly just kind of scattered and mixed together. There's no uniformity. There's no total equalness between all the different minerals. They're all just kind of scattered and unevenly distributed. Some other kind of everyday examples of heterogeneous mixtures would be things like salads. So in a salad, especially like a really good salad like this one, not every single bite is going to be the exact same, right? Maybe one bite has a lot more spinach on it, but the next bite you got a lot more salad dressing on it. One bite you're specifically trying to scoop up a couple strawberries and a blueberry. The other bite you get might have some spinach with the raspberry and some cheese on it. Every single bite is going to be a little bit different than the other one because we have not completely made our salad 100% totally equal, right? All the little strawberry compounds are clumped together in the strawberries. Same thing with the blueberries and then the cheese bits that are kind of mixed in through there. They're not all totally equal. You could get a homogeneous salad if you really wanted to, but that would involve things like an expensive blender, and people tend to call those smoothies. So when you dump this salad in a smoothie and mix it all up and blend it all together and make that kind of smooth, creamy paste, that is more of a homogeneous mixture because now we've taken all of those spinach and blueberry and strawberry compounds and mixed them up totally evenly in our smoothie cup. But when it's as a full salad, then it is heterogeneous. It's not even and equal. Same thing with not just salad, but even salad dressings can do the same. So like this zesty Italian dressing right here. Sure, it's made out of mostly this kind of oil and flavoring combination that makes up the orange background. But then you can also see all these little clumps of peppers and tomatoes and garlic and stuff all in there. That's what makes it a heterogeneous mixture, right? Not everything is completely evenly spaced out. We have all these little clumped areas of peppers and garlic and stuff like that. Same thing for if you were to go outside your house or your apartment and reach down into the bare ground and pull up a big handful of soil. It's not going to be a completely even, smooth mixture, right? There might be chunks of rock in there, like these guys in this soil. There might be sticks and stones mixed in there. Maybe there's like a couple little bugs they accidentally picked up. The soil is not completely evenly distributed, right? Not all of the soil compounds are completely evenly mixed throughout. Instead, we get these clumps of stone and twig and stuff like that. Even in this picture down here, you can see the different colors of the soil. And that's because the colors represent different compounds that are in the soil that give it a certain color. So like maybe this middle area has a lot more clay in it. And then maybe this bottom area where it's kind of light brownish is super silty and sandy. So the different compounds in the soil are not totally evenly mixed. Instead, here they're literally distributed into these layers. So because it's uneven, because it's unequal, it is a heterogeneous mixture. Not everything is equally and evenly distributed. Any questions so far on our different types of mixtures? What a mixture is, the homogeneous mixtures, or the heterogeneous mixture? Anything anybody wants me to go back and review again?
No.
All right. Seems like you guys are feeling pretty confident with the mixtures. So finally, as we wrap up the notes, I wanted to return to this flow chart now that we know a little bit more about the different types of substances that we're talking about. So again, if we have lots of different types of compounds and particles all combined together, we have a mixture. If we don't, if we just have the one single type of compound or element present, then we have a pure substance. If we have a mixture, if all of the elements and particles in it are totally uniform, are totally equally distanced and spaced from each other, then we have what's called a homogeneous mixture. If they're not, if there's unequal distribution, if there's clumps of different types of substances in one areas versus other areas, we have our heterogeneous mixtures. On the other hand, if we do have a pure substance, only that one type of particle is present. If that particle has multiple different elements, all chemically bonded, chemically combined with each other, then it is a compound. If it is literally just one single type of atom with nothing else present, then it is only an element. So mixtures, lots of different particles all together. Pure substance, only one type of particle. Maybe it's a compound that has a couple different atoms bonded together. Maybe it's an element that only has the one single type of atom. If we have a whole bunch of compounds and elements that are different, that are together, we've got our mixture. If those compounds and elements are all totally evenly distributed, it's a homogeneous mixture. If they're not, if they're clumped up and unequal, it is a heterogeneous mixture. And that is all of the notes that go with today's lesson. So for the assignments for these notes that I just went over, they're both pretty short since I know you guys are still working on the midterm. And so each one is only a couple questions, and it's essentially the one assignment spread out over a couple days. So I'll go ahead and show you what they look like. So for the assignment that got posted today, the first page of it has these different, or has a little bit more kind of notes type structure. So it just gives you some more information about like elements and compounds and mixtures and stuff like that. Again, we can see our homogeneous mixture down here on the left, where all of the different elements and particles are more or less evenly distributed, right? There's not one obvious area where there's a whole lot more white elements versus these one black and two white compounds, versus our heterogeneous unequal mixture, where all of the black elements are on the left and then all of the compounds are clumped up in the middle and all of our white elements are clumped up on the right. So that's just some notes to review. The actual homework part is on the second page down here. So each question of your homework goes along with a picture. And so for each picture, I want you to tell me two things. The first one is on this first line here. I want you to write down, is our picture a picture of a pure substance, of a homogeneous mixture, or of a heterogeneous mixture? So one of those three things, pure substance, homogeneous, heterogeneous, goes on the first line. And then the second line is where I want you to tell me if there are elements present, if there are compounds present, or if both of them are present. So in a pure substance, it's only going to be one or the other. But in a mixture, you could potentially have compounds and elements all mixed together. So that's what will go on the second line down here. It's element, compound, or both. So today's assignment is pretty short, just these two questions. If you want to do it on the Google form, it's actually a little bit easier over there. It's the exact same information, the exact same notes, and the exact same pictures and questions. So we still have the same pictures as we did on the doc, but instead of writing it in, you can just pick which type of substance is present. So again, for the first picture, you're going to first pick if it is a pure substance, a homogeneous, or a heterogeneous mixture. And then are there elements present, are there compounds present, or are both of those present? And then same thing for substance number 2. Pure substance, homogeneous mixture, heterogeneous mixture. Are there elements, compounds, or both of them present? So that is the assignment for today. And then the assignment that's going to be posted tomorrow that you can do if you want to get your Friday attendance is essentially just a continuation of that same thing. So the Google Doc and the Google form are set up just like before. You have some different pictures. This time there's 3 of them instead of 2. But for each one, I still want you to tell me what type of substance is present. Is it pure, homogeneous, or heterogeneous? And are there elements, compounds, or both present? So each of the pictures, each of these substances, you need to tell me both of those things. What type of substance, and does it have elements, compounds, or a combination of the 2? Righty. And that is pretty much everything for today. All right, so I know Alicia just dropped out due to her phone battery. Anybody have any questions about any of the stuff that we've gone over so far today? The substances, the mixtures, the compounds and elements, or the assignments for today and tomorrow? Righty, well, Stacy is to be believed. It looks like you all are pretty good.